afternoon.
All right, welcome to the fall semester MAT0028 and MAT0057 final exam review. And because you guys are here and you are not here, you people out there, you're not here, you don't get chocolate. So here, catch. There you go. Chocolate, chocolate, chocolate. All right, and there's more. I expected more people. You guys didn't show up. All right, so the review that I'm going to use is the review that your instructors for MAT0028 or MAT0057 have either emailed to you or have in the math redesign shell. It should be readily available. If you haven't gotten it yet, it's probably because you either haven't looked for it or haven't checked your email. So it is much longer than the actual test. The test is 30 questions. The review is 90 questions. But when I tell you, because I know, because I helped to write the final exam, the final exam is pretty much hidden in here. Not verbatim exact questions, but the type of questions you're going to see on the exam are all in this packet. And then we threw in some other stuff. All right, so it's not going to be exactly like the test, but if you know this stuff, you're going to be in really good shape. So what I'm going to do is, I've asked the people here to tell me what kind of questions they want to go over, and I'm going to go through page by page. Because it is the same review. You guys watching online, you guys can print out the review from your math redesign shell or get it from your instructor, or come by the math department, building 56, room 112 is my office. My assistants are in room 103. And we can get you a copy of it, or we can email you a copy. And that way, when I say I'm doing problem 7, you can look it up on here. You know exactly what we're doing. All right? So let's start with the first page. The first page is order of operations, absolute value, simplifying and evaluating expressions, and properties of numbers. Is there a question you guys want me to go over on this?
Number 2.
Number 2. All right, number 2, kind of a messy order of operations question. 12 divided by, that's a curly bracket. I cannot draw those well. That's the best I can do. 2, and then a square bracket, and then parentheses, 4 minus 6 squared, minus 8 bracket, curly bracket. All right, so order of operations says we do what first? Parentheses. What's the acronym? What do we use? PEMDAS. Right? The sentence, please excuse my dear Aunt Sally. So we do parentheses, then exponents, then multiplication and division together from left to right, and then addition and subtraction from left to right. So when we have parentheses, we basically have to go as far in deep as we can. So we have curly brackets, square brackets, parentheses on the inside. So we're going to do this subtraction first. Now there's a lot of writing in a problem like this because you should really only do one thing at a time. So you just got to write it all out. So this is 12 divided by curly bracket, 2 bracket, 4 minus 6 is negative 2, and that's squared, minus 8 bracket, curly bracket. In case you're wondering, the reason for using parentheses and square brackets and curly brackets is basically just to differentiate what left thing goes with which right thing. That's really all it is. You could do this whole problem with parentheses, but sometimes it's a little harder to read where a parentheses starts and ends. All right, so then we do negative 2 squared is what? This is going to be interactive, guys. Negative 2 squared is what?
4.
4. So this becomes a bracket, 4 minus 8, close bracket, close curly bracket. So we're still dealing with parentheses, right? Even though we call brackets, they're still just parentheses. So 4 minus 8.
Negative 4.
So that becomes 2 times negative 4, which is 12 Now here we still have to do inside parentheses first. So it's going to be 12 divided by -8. And here, I'm just going with simple parentheses so I can really switch. What's 12 divided by -8? All right, does 8 go into 12 evenly? No. What's another way to represent division? Make it a fraction, right? So this is 12 over -8, and then just reduce. It's going to be a lot easier. A positive divided by a negative is negative. We can divide out a 4, and we get 3/2. So -3/2 is the answer. All right? Which, am I right?
Yes.
What's the answer? Better be right. Went to graduate school for a long time to be able to do that. Yes, that is correct, negative. So the answer is C. All right, anything else from that page involving simplifying expressions, evaluating expressions? Let's do number 7. Evaluate 6z squared minus 3z minus 2 when z equals -3. Now the key to this problem, first of all, what do we do? How do we do this? How do we evaluate that expression when z is -3? Come on.
Put in parentheses.
What do you mean?
Wait, what was your question?
Okay, let's do that, and I'm done.
No, anyone has a z, you replace it with negative.
You plug in this case, the -3, and very importantly, as you mentioned, when you write it in parentheses, especially when you have a negative number. All right, and I'll do a little aside on that in just a minute. So this becomes 6 times -3 squared. Did I write that? Is that a minus or a plus? That's a plus. Plus 3z. So then plus 3 times -3 minus 2. And now it just becomes a big order of operations problem. So exponents first. -3 in parentheses squared means -3 times -3 is positive 9. Plus 3 times -3 minus 2. Then we have multiplication. So 6 times 9 is 54. 3 times -3 is -9, so you can write it as plus -9. I think it's a little bit easier just to write it as -9. Minus 2. 54 minus 9 is 45. Minus 2 is 43. Now remember, I mentioned that it's important to when you're plugging in, to plug it in parentheses. All right? So if our expression, say, was just z squared plus 2, what you should do is write the -3 squared like that in parentheses. So -3 times -3 is positive 9, plus 2 is 11. But if you don't write it in parentheses, all right, like the song goes, it's all about the base. And here, identifying what the base is important. Here, the base is technically just 3. This is really a negative sign, and then 3 squared. So this would actually be -9 plus 2. Because it's the negative comes down, and then it's 3 times 3 is 9, which would be -7. And that is the wrong answer. All right, so watch those parentheses when you're plugging in. All right, let me say something about number 10. In fact, I don't really care about the problem. What I want to do is talk about the answers. So number 10, the answers are the commutative, I'm going to abbreviate here, property of addition. The associative property of addition. The distributive property. And lastly, the inverse property. All right, so commutative property. Commute means, right, the root word of commutative is to commute. Commute means what? Move. So if something moves, if something changes places, that's the commutative property. So this particular problem is 3 plus x equals x plus 3. Would be an example of the commutative property because the 3 and the x switch places. The associative property. The root word of associative is associate. All right, what does something associate with? That's in parentheses. So that would be 3 plus 7 plus y is the same as 3 plus 7 plus y. Notice the change in parentheses. Here you could say 7 is associating with y because it's in the parentheses as y. But then y, or 7 gets mad at y for some ridiculous reason, so the 7 is going to now associate with 3. All right, it's like friends in high school, right? Who are you associating with? Who are you not associating with? The distributive property, I think everyone knows that. That would be like 3 times the quantity of x plus 5, and then you distribute the x, or the 3, excuse me, would be 3x plus 3 times 5 is 15. What about the inverse property of addition? It doesn't say that on the test, it should, or on the review. Inverse property will say of addition. What if I asked you this? What is the additive inverse of 5? What do you...
0.
Not 0. 0 is the identity.
1.
No, 1 is the multiplicative identity. 0 is the additive identity. What is the inverse? The additive inverse of 5. There's another word for it. Begins with an O. Opposite. So what's the additive inverse of 5? What's the opposite of 5? Negative 5. So this would be 5 plus negative 5 equals 0. The inverse property is what do you do to get the identity? And the identity for addition is 0, right? The identity is what you do so that nothing changes. In multiplication, the identity is what? What do you multiply by when nothing changes? 1. So the multiplicative inverse is what do you multiply to get 1? And that is the reciprocal. I'm going to step off camera here, get a drink of water. Alright, let's move on to the second page. Here we have solving all kinds of linear equations and some word problems. Some more literal equations with just variables and conversions. All right, so anything on, let's take 11 through 15. Let's say 11 through 14, because I'm going to do 15 anyway. Right, solving equations. Any of those seem challenging? Should I do one?
No.
Oh, let me do one. Let me just do one. For those people watching at home. All right, 14. Solve 2 times x plus 3 plus 7 equals negative 2 times 3x plus 5 plus 5. All right, so what do we do first? solving?
You distribute?
We distribute, right? We can distribute here and here. So distribute the 2 to the x plus 3 is 2x plus 6 plus 7 equals, distribute the negative 2, we get negative 6x, negative 2 times positive 5 is negative 10 plus 5. Now at this point, with my students, I describe this equation as cluttered. You have stuff all over the place. So what we want to do is get stuff a little bit more organized. And how we do that is by combining like terms. Don't start moving stuff left and right quite yet. It's too soon for that. So here we have like terms is 2x plus 13 equals negative 6x, and negative 10 plus 5 is negative 5. Okay. Now we want all the variables on one side, numbers on the other. So I'm going to add the 6x to both sides. Those cancel. So we get 8x plus 13 equals negative 5. Since we have our variables on the left, we want our numbers on the right. So we're going to subtract 13. And we get 8x equals negative 18. Negative 5 minus 13 is negative 18. Divide by 8. You get x by itself. We can reduce. We can divide out a factor of 2. So we get x is negative 9 fourths. All right, that's about as hard as it's going to be on the exam regarding linear equations. All right, I do want to go over, however, number 15. Because 15 is one of those wrinkle questions. How can you tell it's a wrinkle question? It's one of those weird ones. I'll give you a hint. It's not about the question. It's about the answers. For number 15, what are the weird answers?
B and C.
B, which is all real numbers, and C, which is the empty set or no solution. So whenever you see one of those in a question, realize that, okay, it's a possibility something weird might happen. So let's solve. This is 15. Let's solve. 3 times x plus 2 minus 5 equals 4x minus x plus 1. Well, this has another good thing in it too. So we're going to distribute the 3. So we have 3x plus 6 minus 5. And this is 4x. Now this you got to be careful of. Whenever you have a minus and then something in parentheses, I think the best way to think about it is put a coefficient of 1 in front of that parentheses and then distribute that negative 1. So this becomes negative 1 times x is negative x, and negative 1 times 1 is minus 1. So when we combine like terms on the left, we get 3x plus 1. When we combine terms on the right, 4x minus x is 3x minus 1. What is the confusion?
I think you lost me at when you put the coefficient 1.
Well, and then distribute. So negative 1, like here I distributed the 3, correct? So distribute the negative 1. Negative 1 times x is negative x. Negative 1 times positive 1 is negative 1.
Okay.
Then I have like terms here and here.
Okay.
All right? So I always like to act on x first. X, my variable. My variable is my focus. So I'm going to subtract the 3x from both sides. And notice what happens. Both of these cancel. So what are we left with?
1 and 1.
Well, a 1 and an equals, and on the right we have a minus 1. Don't make it up. Don't say, well, I can't cancel both, so I'm just going to put an X in there. Don't make stuff up. Okay, this has been around for 1,000 years. If you're making it up, you're doing it wrong. It's that simple. So in this case, we get to a statement of two numbers. That one number is equal to another number. And I'm going to ask you, when is 1 equal to -1? When is that true? When is the number 1 equal to the number -1? Never. Those are different. So this is never true. And remember that a solution to an equation are the numbers that you can plug into that equation where you're going to get a true statement. Well, in this case, I can never plug anything in and get a true statement. This is always false. It's never true. So I can't plug anything in that'll make this true. So there is no solution. Which can also be written as the null set, or it can actually be written as an empty set, a set of curly brackets with nothing in it, literally an empty set. Either one of these is acceptable. Now, let me take a question really from this point. So let's say we had a similar question where you had -4x plus 7 equals -4x plus 7. Something like that. So I want to get the x's together, so I'm going to add 4x to both sides. And they both cancel. So in this case, you get 7 equals 7. Well, when does 7 equal 7? When is the number 7 equal to the number 7? Always. It's always true. So that means if this is always true, that means the original equation, which it would have come from, is always true. So that means any number I plug in will yield a true statement. So that means everything's a solution. Right? So this means that everything is a solution. And mathematically, how do we say that everything is a solution? We say our solution is all real numbers. The kind of equations that you deal with what are called real numbers. For you guys, real numbers is everything. All right, as you take more math classes, you realize there's more than that, but that's okay. All right, so all real numbers. So when you get one of these funky problems where the variable cancels out on both sides, if you get a number is equal to something else, that's never true, so you know it's no solution. If both variables cancel, or all the variables cancel, and you get a number is equal to itself, that's always true. So everything is a solution. So the answer is all real numbers. All right, let's do 16. Okay, why is 16 for you guys a challenging problem? Guys, why is 16 challenging? Those of you playing at home, look at number 16. Why is number 16 challenging? It's not the math.
It's the words.
It's the words. It's a word problem. All right, and I'm going to read it. If 4 out of every 7 groundhogs carry a gene for a defective enzyme, how many groundhogs carry the defective gene in a population of 840 groundhogs? Set up an equation and solve. All right, this is what's called a proportion. You're given kind of an original setup, and then you're asked to apply that to a bigger problem. Now, when solving a proportion, the most important thing is not the numbers. It's the words. All right? So we've got a 4 out of 7. Okay? But what does that 4 represent? Reading the first part of the first sentence. If 4 out of every 7 groundhogs carry a gene for a defective enzyme. What does that 4 represent? a group of what?
Groundhogs?
Is it the total ground? Okay. There are basically two types of, well, not two types of groundhogs. We've got the defective enzyme groundhogs, and we have the total number of groundhogs. Right? That 4, is that the total, or is that the ones with the defective enzyme? That's the ones with the defective enzyme. So it's 4 defective out of 7 total. Right? 4 out of 7 have the defective enzyme. So when I set up the other fraction in the proportion, the words have to match. This is going to be my defective, and then this is going to be my total. And then I put the numbers in that match the words. The words have to match like that, horizontally. So the second part of the question, how many groundhogs carry the defective gene in a population of 840 groundhogs? So that 840, is that the defective or is that the total? It's the total. And we're asked to find how many carry the defective gene. So how many are defective? That's my unknown. Because if you just take the numbers and you just throw them in a proportion, you're probably going to get it wrong. Because you're just throwing numbers together. You're making a number salad. Alright? It's got to match. So now that the words match, I'm just going to do the math. Alright, so how do we solve a proportion? Like this.
Cross multiply.
Cross multiply. Alright, so this becomes 4 times 840 equals 7x. I'm going to teach you a little trick here. You can multiply this out if you want. No problem with that at all. I'm not going to. I'm going to solve for x and divide by 7. Why am I going to do that? Well, because I'm good at arithmetic. And I know that 7 goes into 84. How many times? 12. Okay, 7 times 12 is 84. Alright, those of you watching at home, think touchdowns. Although teams don't normally score 12 touchdowns, but 12 touchdowns is 84 points. That's how I learned that as a kid. Alright, so I can say 7 goes into 84 12 times, so 7 goes into 840 120 times. So I'm dividing before I'm multiplying and my numbers are smaller. So then I get x is 4 times 120 is 480, excuse me. Now I know some of you are thinking, what did he just do there? Oh my goodness, that is ridiculous. So I'm going to go ahead and do it the more traditional way, where when we cross multiply, we get 4 times 840 equals 7x. Okay, so I've got to do 4 times 840. So 840 times 4 is 0, 16, carry the 1. 8 times 4 is 32, plus 1 is 33. So now we're going to divide by 7. Alright, long division. Yay, everyone's favorite. So 7 goes into 3,360. 3 goes into 33 4 times, minus 28 is 5. Bring down the 6. 7 goes into 56 8 times. 8 times 7 is 56 is 0. Oops, that looks like a 6. That's wrong. 56 subtract, we get 0. And we're done, so we fill in the zeros. And what do we get as the answer? 480. What do we get before as the answer? 480. Which way was easier? My way. Okay? Arithmetically, using the arithmetic, this was actually a little simpler. It's very counterintuitive. It's not what most students would do, but it is, there's nothing wrong with it, with the arithmetic. All right, let me go ahead and do 17 and 18. Those are always problems for students. This is when you're solving equations that don't have numbers. It's the literal equations with just variables. All right, so let's solve, this is number 17, solve for z. K times y plus m times z equals a times b. All right, so we're solving for z, so I'm going to put a little box around that. Okay? Now, I'm also going to write a parallel equation, meaning an equation that pretty much is the same thing, but looks very different. All right, so I'm going to say 8 plus 3z equals 11. All right, I have an expression plus something times z equals another expression. That's what I have here. An expression plus something times z equals another expression. Now here, how do I solve this? This is easy. How do I solve this equation? My students who are sitting in the room better know this. Forget this. Forget this. Look at this. How do we solve this equation? Subtract the 8, right? Well, that's that expression all the way on the left. So in this case, I'm going to subtract the expression all the way on the left. So I'm going to subtract ky from both sides. These cancel. Now, here on the right, these would cancel, and I get 3z equals 3. I subtract, or I simplify, because I can. But how did I get that 3? How did I get this 3 right here?
From 11 minus 8.
I did 11 minus 8. So what if I just left it as 11 minus 8? Well, I can do that here. This becomes mz equals, and if you read this, if you just read it, it reads as ab minus ky. So you know what you write? ab minus ky. That's how it reads. So again, I'm solving for z. Now in this equation, what do we do? Divide by 3, right? How do you undo multiplication by 3? You divide by 3, inverse operations. And you would get z is 1. Because here I can do 3 divided by 3 is 1. Here, well here I divided by 3 because z was being multiplied by 3. Here what am I going to do? Divide by m because z is being multiplied by m. It's the same reasoning. So divide by m, these cancel. In this case, there's nothing for me to do, right? There's no arithmetic for me to do, so I leave it, and I'm done. So z is ab minus k times y over m. Right? They're not different. Right? You think they're different, but they're not. All right, let me do 18 as well. So that's solve for A. So A over B minus C equals D. Now there are a couple of different ways to do this problem. That makes it a little bit more challenging. What do you guys think if we're going to try to get A by itself? Okay. what's one strategy that we can use? First, you got two options here. Not everyone at once, please.
Multiplication.
By what? By B. Why?
Because it's being divided.
Because, well, we have a fraction, right? And what do we think of fractions? Right? We hate fractions. Right? So when you don't like something, what do? Get rid of it. So we can, one of our options is to clear fractions. So we multiply both sides by B. That's perfectly acceptable. So when we distribute, and I'm going to write out a lot of extra steps here, we get B times A over B minus B times C equals, and I'm just going to put this in alphabetical order, B times D. D times B, B times D. It's the same thing. Then I can think of this as B over 1, and then these cancel. So I end up with A A minus BC equals BD. Now again, if we're solving for A, in this case I have subtraction with A. So how do I get rid of subtraction? Addition. So I'm going to add the BC over to the other side. These cancel. So we get A is equal to BD plus BC. Now the correct answer in the packet is BC plus BD. Is that the same as this? But it's addition. Does it matter if it's backwards?
No.
No, because addition is commutative. So BC plus BD, which is choice A on the review, is the same thing. Now the other way to do this is to not get rid of the fraction first. Is to actually add the C over. So if we add C to both sides, and we get A over B is equal to C plus D. D plus C or C plus D is the same thing. And then we multiply both sides by B to clear fractions. It's like multiplying through by a common denominator. Think of this as B over 1. So the B's cancel. And you get A equals, and when you distribute, you get B times C plus B times D, and you can see that these are the same. Right? Here, remember, these answers, they look backwards, but they are equal because addition is commutative. Right? We can change the order. Right? Is one way better than the other? I really don't think so. I think it's about the same. All right? What I would tell you is go with some instinct. Some of you are going to say, you know what, let me get rid of that fraction first. Some of you are going to say, okay, let me isolate the A part first. So let me add the C over. Really doesn't matter. All right, and then number 19. All right, this is a question you really want to know. I mean, you really want to know this one. It's important. You guys catching my drift? I don't think you're catching my drift. You know what that means to catch my drift? To really understand what I'm saying. It's really, really important on Monday for you.
Okay.
All right, so we're going to convert. This is number 19. 85.7 inches to centimeters. Now, I don't know how your teachers teach you to do this. This is the one thing that I teach that I believe the science people do it better than we do it as math people. The best way I learned to do this was how I learned it in high school chemistry, using something called dimension analysis. All right? So here's how I do it. I write a line. And I start with what I'm given, which is 85.7 inches. And I draw a line. And I'm going to think of these as fractions. Okay? So we're given the conversion in the problem that 1 inch is 2.54 centimeters. Because the problem students always have is, okay, I know I'm going to multiply or divide. Which one do I do? I don't know. All right? My way takes care of that. So we want to convert inches to centimeters. So we want to get rid of the inches and we want to keep centimeters. We're going to think of this like canceling. If I want to cancel inches from the top of a fraction, I'm going to have to cancel it with inches on the bottom of the fraction. So that means my inches are going to have to go down there in order to cancel with the ones up here. So that means this has to be centimeters. And 1 inch is the same as 2.54 centimeters. Now in this case, if I think of this as a fraction, 1 inch is equal to 2.54 centimeters. So if I have a fraction where the numerator and the denominator are equal, what is the value of that fraction? 1. It's 1. So if I take something and I multiply by 1, am I changing the value? No, I'm just changing what it looks like. It's like getting a common denominator. If you take a fraction and you multiply by 5/5, you're not changing the value, you're just changing what it looks like. So look at what happens here. The inches, top and bottom, cancel. Now because both of these are in the numerator, what am I going to do with them? If you think of these as fractions, if I have two fractions, what would I do with two numerators like that? I would multiply. Am I going to divide? No, because I'm not dividing by anything other than 1. If this, say, was a centimeters problem and this was flipped, and then I'd end up with a 2.54 in the denominator, then I would divide by 2.54. So the question is, do I multiply by the 2.54 or do I divide by the 2.54? If you set it up this way, it tells you what you should do. In this case, I should multiply. So 85.7 times 2.54. Okay. So that's 8. That's 28 carried 2. So that's 22. That's 32 and 2 is 34. Put a 0. Multiply by 5. Let me get rid of these now. 5 times 7 is 35. 5 times 5 is 25 plus 3 is 28. 5 times 8 is 40 plus 2 is 42. And then 2 zeros. Get rid of those. 2 times 7 is 14, carry the 1. 2 times 5 is 10, plus 1 is 11. And 16 and 1 is 17. And you have to add. So that's going to be 8, 7, 16, carry the 1. 3, 4, 5, 6, 7. That's 11, carry the 1 is 2. And how many decimal places?
3.
3 in my final answer, right? 1, 2, 3. So 1, 2, 3. So it's 217.678. So the correct answer is actually 217.68 is what's on the test. Okay? Remember guys, this is just arithmetic. As ugly as it is, it's just arithmetic. Alright, page 3. Alright, is there anything you guys want me to do on that? I'm again going to step off camera, get a drink of water. I'm going to pull Senator Rubio. What number?
27.
27. All right, 27 is a linear inequality. Solve for x and graph. So we have 7 minus 5 times x plus 2 is greater than or equal to 6 times 3 minus 2x. So what do we do first here on the left? We distribute. What do you think a common mistake would be here? Don't subtract. I think that's what some students would do first, and that's wrong. Remember, multiplication first, order of operations. You have to multiply before you add or subtract. So distribute what? The negative 5, not just the 5. So this becomes 7, and then negative 5 times x is negative 5x. Negative 5 times 2 is negative 10, is greater than or equal to, here we distribute the x, or the 6, excuse me, and we get 18 minus 12x. Let's combine like terms here. We get negative 5x, and then 7 minus 10 is negative 3, is greater than or equal to 18 minus 12x. Now, when solving an inequality like this, I strongly recommend moving the variable to the left-hand side. Because when you read an inequality, you always want to have it in terms of your variable first. X or Y or Z is greater than, less than or equal to, whatever, and then some number. Very strongly recommend that. If not, you can get the graph very, very wrong. So I'm going to add the 12x. Those cancel on the right. And we end up with 7x minus 3 is greater than or equal to 18. We're going to add the 3. And we get 7x is greater than 21. Write it up here. Greater than or equal to, sorry. Divide by 7. So x is greater than or equal to 3. Alright, now, depending on your instructor and how you learn how to graph, alright, there are a couple of different ways to do this. Alright? Some of you who did, well, you've all used ALEKS in your classes, but it depends on the instructor. If you have greater than or equal to or less than or equal to, the most important thing is that you have an equal to. When you draw the graph, it would have the filled in circle. But when you use the interval notation, remember it would have the brackets. So you can use the brackets also on the number line. It's the same thing. If it was just greater than or less than with no equal, then we would graph an open circle. And then when we did interval notation, we would have parentheses. And again, you can also use those on the graph. So in this case, I'm just going to write it up here. We have the x is greater than or equal to 3. So you can put all kinds of different numbers on here. And again, you have to pick the right answer. But the most important number in drawing an inequality, graphing an inequality, is the number in the solution, 3. To me, that's all that matters. So I'm just going to pop that in there, 3. Now, because it's greater than, I'm going to shade which way. Which way is greater than 3? Which numbers are greater than 3? To the right. So you're going to shade in this way. Now with an equal to, we can have the closed, right? So the dot or the brackets. On the exam, you're going to see brackets or parentheses. Okay, this is what you need to know for the exam. But realize the connection between the two. All right, so it's going to be a bracket always opening in the direction of the shade. And so that would be the answer, which is C on the review. All right, let's do one of either 22 or 23. Let's do 22. That's about discount and sales tax. That's one that usually students have trouble with. Because again, it's another word problem. All right, 22. Jamal buys clothes at super discounts. On Saturday, he bought shoes regularly priced at $40 for 25% off, and a jacket regularly priced at $100 for 30% off. Then including a 6% sales tax, what total amount will Jamal pay? Okay. So I'm going to do this problem strictly by the book. There are a couple different ways to do this. You could actually use fractions for some of these, because 25% is 1/4, 30% is 3/10. It's really not too bad, but I'll do it the really traditional way. So what we have to do is we have to find out what the discounts are and subtract them from the total. So 25% off of 40, so that's 40 times 25% or 0.25. Make sure we don't need the 0. So when we do that, 5 times 0 is 0, 5 times 4 is 20, 0, 2 times 0 is 0, 2 times 4 is 8. So that's going to be 10 with 2 decimal places. So this is the discounts. This is the discount. So if the discount was $10, all right, what was the sale price? How do I determine the sale price?
40 minus.
It's what it was, 40 minus the discount of 10 is $30. All right, so he paid $30 for the shoes. So now we look at the jacket is $100 and it's 30% off, or just 0.3. You don't need to do 0.30. So when we multiply, 3 times 0 is 0, again, and 3 with 1 decimal place. Now if it makes you feel better, you can put another 0 there to call it $30.00, but it's just 30. All right, so this is the discount. So then what's the sale price? How much did he actually pay?
70.
70, right? The original 100 minus the discount of 30 is $70. Okay? Now before tax, how much did he pay? He paid $30 for the shoes plus $70 for the jacket, so he's already paid now $100. But then we have to compute sales tax. Sales tax is 6%. So $100 times 0.06, right? 6%, you got to move the decimal over twice. That's going to be 0, 0, and 6 with 2 decimal places. 2 decimal places, excuse me. Which is how much? $6. Okay? So it's $100 plus $6 in tax is a total of $106. Now there are other ways of doing some of the arithmetic here. For example, what I like to do for a problem like this and say, if something is 25% off, how much are you paying for it? If I take away 25%, how much is left? 75%, right? 100% is everything. So if I take away 25%, what's left is 75%. So if I do 40 times 75%, or 0.75, I get 0. 5 times 4 is 20. Put the 0. 7 times 0 is 0. 7 times 4 is 28. Add, and we get 30. 2 decimal places gives us 30. Notice that that answer is what we got when we did the sale price. But we did it in one step instead of 2. All right? If you don't like what I just did, don't do it. All right? But it is an option. This is how I would do something like this. Same thing here. Instead of a 30% discount, I can say if 30% is missing, 70% is left. 100 times 70% is 70. That one's pretty obvious. All right? So that's some shortcuts. All right, let's move on to the next page. Exponents. All kinds of fun stuff with exponents. Positive and negative exponents. Is there a particular problem you would like me to do there?
Yes.
What number?
33 and 35.
33 and 35? Okay. Is simplify x to the third over 4y to the negative 2 power. Now, I think one of the issues that students have with these problems is there really is no one right way to do it. There's a set of rules that you're allowed to use, but it's not like solving equations where you should do a certain thing first and then a certain thing second and a certain thing third. We have some options here. What I would recommend for this problem, because the only negative exponent is on the outside. Okay? Remember, when you see a negative exponent, what does that tell you to do? What does it mean, a negative exponent? So let's define this. X to the minus n is equal to what? How do we define x to the minus n? 1 over x to the n. So the negative exponent means reciprocal. It means flip it over. So if you have a whole fraction to a negative power, you can reciprocate or flip the whole fraction. And that makes the exponent positive. So this becomes 4y over x to the third, right? Just flip the whole fraction over to the second power. Then we apply the exponent to each thing in the base, each thing that we're multiplying. So this becomes 4 to the second times y to the second over x to the third to the second. Now, depending on how good you were at this when you first did this, some of you can do from this step and go straight to the answer without writing this out, and that's perfectly fine. If you need to write this out, that's fine too. So 4 squared is 16. Y to the second is just y to the second. And then x to the third squared. So when we have a power to a power, what do we do to the exponents? Do we add or multiply?
Add.
Multiply. So that's x to the 6th. Remember that x cubed squared. Anything squared means that something times itself. So don't think of this as x to the cube. Think of it as I'm multiplying 3 x's. Here I'm multiplying 3 more x's. So how many x's total am I multiplying?
6.
How many? 6. Right? If I'm multiplying 3 x's and I multiply 3 more x's, I'm multiplying a total of 6 x's. That's x to the 6th. Alright, so this would be the answer. The other way to do this problem, which for this particular problem I would not recommend. Notice in this step how we applied the exponent of 2 to each thing that we were multiplying or dividing in the fraction. You could do the same thing there. But that's going to give you a whole bunch of negative exponents. My advice to you is don't do anything that's going to cause you to have more negative exponents. You want to have fewer negative exponents. I think that's a better approach. All right, and then 35 you said?
Yes.
All right, for 35, I'm going to do this one 2 ways. I'm going to do it the traditional way, which is I'm sure how many students have done it. Then I'm going to do it my way. So we have simplify x to the negative 2, y to the negative 1, z to the 2nd, over x to the 3rd, y to the 0, z. Now the one thing we can actually write that's not there is, we can call this, if we want, z to the 1st. Now the traditional way of doing this is to say when you divide like bases, you subtract the exponents. So this becomes x to the negative 2 minus 3 times y to the negative 1 minus 0 times z to the 2 minus 1. Then you would subtract the exponents. This becomes x to the negative 5, y to the negative 1, z to the 1st. Right, just doing that subtraction in the exponents. Then, anything with a negative exponent gets flipped. So things in the numerator go to the denominator, things in the denominator would go to the numerator. So since we have negative exponents in those 2 factors, they're going to flip. So the z stays where it is, z to the 1st or just z, and then the x to the 5th and the y to the 1st, or really just the y, go underneath. That's not the way I generally teach it. My philosophy is, let's get rid of the negative exponents first. Alright, so x to the negative 2, y to the negative 1, z to the 2nd, over x to the 3rd, y to the 0, z to the 1st. Alright, so I use the philosophy of a song, famous song by a band called Clash, Should I Stay or Should I Go? So we're going to go through each thing and say, should it stay or should it go? Meaning, should it flip top to bottom or bottom to top? All right? So z, or x to the negative 2, stay or go?
Stay.
Why stay?
Go.
Go, right? It's got a negative exponent, so it flips down to the bottom as x squared. Y to the negative 1?
Go.
Flip, right? Y to the 1st. Z to the 2nd?
Stay.
Stay. X to the 3rd?
Stay.
Stay, because it's a positive exponent. Now this one's kind of a trick. What's y to the 0 power? Anything to the 0 power is
It's
1. Anything to the 0 power, right? As long as actually anything except 0 to the 0 power is 1. Alright, I once gave a problem when I was teaching. It was something like this. That whole big mess to the 0 power.
1.
Answer is 1. Doesn't matter what the inside is. Answer is 1. Students didn't like that. So what do I do with this y to the 0? I don't even need it. I ignore it. Because it's really just 1. And what does multiplying by 1 do? What does that change? Nothing. All right, and then the z, stay or go? Stay. So then I'm going to multiply, oops, hold on. This is a z to the second. Now if I have common bases in either the numerator or in the denominator, just 1, then I'm going to multiply. And notice that in the denominator I have an x squared times x to the third, which is x to the fifth. Then I have a y, and then I have a z. Now as far as the z's, top and bottom, all I want to do is cancel. That's it. I'm going to cancel. How many z's are in the numerator? 2. How many are in the denominator? 1. How many can I cancel?
1.
I can cancel 1 from 1, leaving 1 left. Where is it? It's in the denominator. Or it's in the numerator, because that's where I had more to begin with. That's where my leftovers are. So the answer is z over x to the fifth y. Notice that we get the same answer. The reason why I prefer this method is, other than arithmetic of fractions, adding and subtracting fractions, this is the arithmetic that students in this class are the worst at. Adding and subtracting negative numbers. I know it, you know it, you guys know it. Alright? Adding and subtracting negative numbers is a weakness. So avoid the weakness. That's my philosophy. So this is the way I like to do it. If this is the way you learned it from your teacher and this is what you're comfortable with, Godspeed. Okay? Then do that. Alright? The important thing is, on the test, do what you're comfortable with. Alright. Any others from that page? Scientific notation, you guys are okay with that? Alright, then what about the next page? Multiplying, adding, subtracting, or dividing polynomials. This is numbers 37 to 44. I think the adding is pretty easy. Remember, just combining like terms. Let's do the subtraction. Let me do the subtract. Let me do 41st. We're actually running out of time here. Well, I'll tell you what. Do you guys want me to do any of those? Adding, subtracting, multiplying, dividing?
Okay.
You'd rather I get to the harder stuff? Okay. Alright, next page on factoring. Well, let's go through some of these. 45 has 4 terms, right? Factoring with 4 terms. How do you factor with 4 terms? Begins with a G. Grouping. Right? Factoring with 4 terms is factoring by grouping. Making sure you take out the greatest common factor first. Okay? Any other of the factoring or solving quadratic equations you would like me to do there? 52? Alright, 52 is about as challenging as it's going to get. 6x squared minus 7x minus 3 equals 0. So, depending on your instructor, there are some different ways of doing this. I do not do guess and check. I do splitting the middle term, or the AC method. So I need to find, and I have my own little system that I use. I need to find, that's an x for multiplication, not x is in the variable. So I need to find two numbers that multiply to 6 times negative 3, which is negative 18, and add to the middle term, which is negative 7. So two numbers that multiply to negative 18 and add to negative 7 are negative 9 and positive 2. Right? Those multiply to negative 18 and add to negative 7. So I'm going to split the middle term to 6x squared, and then when I split, I get negative 9x plus 2x, and then minus 3 equals 0. We group the first two terms and the last two terms. Here I have a common factor of 3x. I'm left with 2x minus 3. Here, this is a little tricky. What's my common factor there?
1.
You're saying, well, there isn't one. That's exactly correct. When you don't see a common factor, by default it becomes 1. But it's important to write it. We get 2x minus 3 equals 0. Here you can see we have a common binomial factor. So when we factor that out of 2x minus 3, we're left with 3x plus 1. That's why it's important to write the 1 so you know to put it in here. So now we use the zero product property. Right? If you multiply two things to get 0 as an answer, then one of those two things is 0. So we get 2x minus 3 equals 0. 3x plus 1 equals 0. Add the 3. So 2x is 3. Divide by 2. So you get x is 3 halves. Here, solve, we subtract the 1. So 3x is negative 1. Divide by 3, so x is negative 1/3. So those are my two answers. Okay? Any others on that page?
53 will do the same thing?
What number?
53.
53 is pretty much the same thing. But there's one important step first. That in order to solve a quadratic, quadratic means of a square. That means it's going to be a squared in it. So solve 5x squared minus 8 equals 18x. The first thing you have to do is make sure that it's equal to 0 like this one was. So what you have to do first is move this minus 18x over. And it's very important. Notice how I wrote that. I kind of put it in the middle. Because when you write your polynomial, you want it in decreasing order by exponent. Square, then x to the first, and then just your number. So this becomes 5x squared minus 18x minus 8 equals 0. And then you would go through exactly the same process. All right, you would find two numbers that multiply to 5 times negative 8, which is negative 40, and add to negative 18. It's going to be negative 20 and 2. And then you would go through the same process. All right, the next page, 55 to 61. Let me do 61. Because 61 is a little tough. These problems are simplifying, multiplying, dividing, adding, and subtracting rational expressions. Now the simplifying and then the multiplication and division, those are fairly easy. It's factor and then cancel top to bottom. The only wrinkle is with a division, right? Some people call it the keep, change, flip. That you have to multiply by the reciprocal of the second fraction. But subtraction is a little tricky. And that's negative 4a plus 3 over 3a squared minus a minus 5 over 3a squared. Now, when adding or subtracting fractions, what do you have to do first? Anytime you add or subtract fractions, forget this problem. Anytime you add or subtract fractions, what do you have to do first? We just add. What?
Make sure the denominator is
Common denominator, right? Anytime you add or subtract fractions, you have to have a common denominator. Luckily, in this case, we do have a common denominator. But here's where it gets tricky. What I recommend you do is put parentheses around each numerator. Then, without getting rid of much of anything, write it as one fraction. And what you end up with is you have one fraction with a common denominator of 3a squared. Then keep everything else exactly the same. Parentheses, minus 4a plus 3, minus parentheses a minus 5. Believe it or not, that's a really important and helpful step. Because what you have to do here, we talked about this with a problem earlier, is we have to subtract something in parentheses, which means we kind of have to put a 1 in there and distribute that negative 1 or distribute the negative, depending on how you want to say it. So then this becomes the negative 4a plus 3, and it becomes minus a plus 5, because it's negative 1 times negative 5. It's a positive. Over 3a squared. Now we can combine like terms. Negative 4a minus a is negative 5a. And 3 plus 5 is 8. All over 3a squared. Now, if you don't do this step with the parentheses and then distributing the negative 1, let's say you just take that problem and you just combine the numerators. What you will end up writing, and incorrectly, is the following. You'll write negative 4a, okay. Then I have a plus 3. Then I have a minus a, and then I have a minus 5. And notice what happened. The 5 is the wrong sign. Because this negative here was not distributed. Right? It's got to be distributed. That's the key. Now, because I helped write this test, and because I'm really good at writing wrong answers, okay, a problem like this, if it were on the test, you can bet there would be an answer where if that was the mistake, what would the result be? Okay, so if you were to combine, you'd get negative 5a squared. 3 minus 5 is negative 2, oh, excuse me, 5a. Minus 2 over 3a squared. You can bet that would be a wrong answer. Hold on, is this one of the wrong answers?
Yeah.
It is. This is one of the wrong answers. Because that's the mistake we expect you to make. All right, and we're not doing our jobs if we don't give you reasonable wrong answers on a multiple choice test. Right? If we were to give you a test and say, what is the capital of Russia? The answers are A, Moscow, B, purple, C, 4, D, Mars. You don't have to know a lot about world geography to get that right answer. Okay? All right, what about the radicals? Any questions on the radicals? Adding, subtracting, multiplying, rationalizing the denominator.
Number 64.
64. Okay, adding and subtracting a radical expression. All right, 64. Add or subtract 9 square root of 2 plus the square root of 162 minus 3 square root of 50. Now again, depending on your instructor, you may have done this different ways. You may do some factor trees. I like to use what I call the biggest square method. So I want to factor all of these radicanes, the number under the radical is called a radicand, so that one of the factors is the biggest perfect square possible. I don't like factor trees. So I'm going to do these separately, kind of on the side. So the square root of 162, that actually factors to 81 and 2. Now if you don't see that, then you may have to do a factor tree and get all your prime factors. Well, what's the square root of 81? 9. So this becomes 9 times the square root of 2. 50, the square root of 50, factors to 25 and 2. 25 being the biggest perfect square that goes into 50. Square root of 25 is 5, and we're left with the square root of 2. To me, it's important that you write that square first, because out of habit, that's going to be the one you're going to get rid of the radical on. Just remember, when it comes to radicals, I have a rule. It's write what you say. If I ask you, what's the square root of 25? 5. So what do you write? Just a 5. There's no radical sign, because you didn't say square root. So now I'm going to take those, and I'm going to put them back in here. So this is 9 times the square root of 2, plus, here there was no coefficient, so this is easy. Square root of 162 is 9 times the square root of 2 again, minus 3 times square root of 50 is 5 times the square root of 2. So I do have a little bit of arithmetic to do there. I have to multiply first. So this is 9 times the square root of 2 plus another 9 times the square root of 2 minus 15 times the square root of 2. Now remember, when adding and subtracting radicals, it's really just like terms with variables. Right? If I have 9 square roots of 2, and I have another 9 square roots of 2, and I take away 15 square roots of 2, I have to have that same object, right, that I'm adding or subtracting. So 9 plus 9 is 18, minus 15 is 3 square roots of 2. All right? All I'm doing is adding and subtracting those numbers on the outside. If this was a variable expression, 9x plus 9x minus 15x, we would simplify it the same way. Right? When we're adding and subtracting like terms, we add and subtract the coefficients. 9 plus 9 is 18, minus 15 would be 3x. Right? The analogy is the same. It's the same idea. Okay? Any other radical questions? All right, number 65 is basically the same thing, right? You just got to factor those numbers. It helps being good at arithmetic, or knowing your squares, right? 1, 4, 9, 16, 25, 36, 49, and so on. All right, what about any of the graphing? X and Y intercepts, slope, graphing lines. All right, what about if we talk about some of these? Numbers 75 and 76. How do you find the y-intercepts of a line? How do you find the y-intercept of a line?
Y squared x plus
You don't need to do that. No, that's y-intercept form. Or slope-intercept form, excuse me. The y-intercept. How do you find the y-intercept? Well, actually, hold on. Let me rephrase that. You could do y equals mx plus b. But there's a better way. All right? Remember, the y-intercept is where the line crosses the y-axis. And on the y-axis, you know that x is 0. Right? So to find the y-intercept, you set x equal to 0. To find the x-intercept, you let y equal to 0. Now, looking at the answers here, okay, you can kind of, I'm okay with teaching you guys how to take the test a little bit. When we do this, and we're going to get an answer for y, and then we're going to write the ordered pair. So the ordered pair is going to be we know we're going to have an x of 0, and we're going to have some y, which we're going to figure out what that is. So the answer better have a 0 in the x, and then a y. So you can just tell by these answers, C and D have an x comma 0. Those are wrong. But I bet you if you plug in the wrong place, one of those will be the answer. All right? Similarly here, since we know y is 0, we're going to have some x we're going to have to figure out, right, using some algebra. So we know, which answers are obviously wrong. All right, how do you calculate slope? What's the fraction of words with slope? They don't know. Do you know? Rise over run. Okay, slope is rise over run. Okay, look at number 77. Okay, for something like that, all you have to do is count the points. And you always go from left to right. Now, first of all, as you look at the graph from left to right, is it going uphill or downhill? If you draw a little stick figure guy on the left side of the line, is he walking uphill or downhill? Uphill. That means it's a positive slope. If he's walking downhill, it's a negative slope. So in this problem, and I'll just graph this very quickly. You have an x-intercept at -3 and a y-intercept of 5. Obviously, on your test, you'll have numbers and it'll be pretty, right? So in this case, we go, or let's say slope is rise over run. So to go from here to here, we go up 5, and then we go, make it dotted, right 3. Now if you go the other way, it's the same thing. If you go right 3, up 5. But your rise is 5, your run is +3, so it's 5/3. You don't have to use the slope formula if you're given a picture. All right, so if you're given a graph and you have to find the slope, just rise, how many up or down? Run, how many left or right? All right, given the equation of a line, the best way to find the slope is to put it in slope-intercept form. So this is number 79. This was, by the way, 77. Number 79 is 3x minus 4y equals 16. So we want to put it in slope-intercept form, which is y equals mx plus b. That means get the b by itself. So subtract the 3x, and we get -4y equals. Now here, this reads as 16 minus 3x, which is not wrong. But it's easier to put the x first. All right, so we have it closer to slope-intercept form. So it's a -3x and a +16. Then when we divide by -4, these cancel. So we get y is positive 3/4 x, and then 16 divided by -4 is -4. Now where's the slope? How do you identify the slope?
The one of the x.
It's the coefficient of x, right? The slope is m, so the slope is 3/4. All right, number 80 is essentially the same thing, and you would get -6/5 when you work it out. All right, number 82 is hard to read. Again, those of you watching at home, but it looks like there's a vertical line through -4. And when you have a vertical line is always of the form x equals. And so since it's through -4, it would be x equals -4. But that's not one of the answers. Notice that all the answers are equal to 0. So just add the 4 over to the other side, and you get x plus 4 is 0. All right, it's hard to tell from the picture. On the test, on the exam, it's much easier to read. All right, if it's a horizontal line is of the form y equals a number. All right, are there any other questions? Graphing or otherwise? Because we're pretty much out of time. We've gone a little bit more than an hour and a half. Any questions? Yes. What?
The test, when can we take it?
Well, because you're in my class, I'll talk to you privately. That's when I tell the whole world when you're going to take your exam. Okay? All right. I'm going to leave you guys with one parting thing of wisdom, all right, about studying for the finals. And this is a final in any class. Studying for a final exam is about remembering what you've forgotten, what you've learned. All right, remembering what you've forgotten, what you've learned. You saw all of this stuff and then some in your classes this semester. You just don't remember. So what I recommend you do is sit down with the review, either the departmental review or a review that maybe an instructor gave you, or go through ALEKS, right? If you've taken a final comprehensive assessment, you can use that as a guideline. And that'll tell you what you know. Then focus your energy on what you don't know. That's the biggest part. You individually, you've got to figure out what you remember and what you don't. If you remember it, move on. Focus on the stuff you don't remember, and that's what you study. All right, so for those of you that are here, thank you for coming. For those of you that are watching online, thank you for watching. Good luck on your final exams.